Functions and relations are fundamental concepts in mathematics, often explored in discrete mathematics, as they provide a foundation for understanding structures and patterns in various fields, including computer science, logic, and engineering. A relation in mathematics is a way of associating elements of one set with elements of another set. Consider two sets, A and B. A relation between these sets consists of a collection of ordered pairs, where each pair contains one element from set A and one element from set B. For example, if set A represents people and set B represents their ages, a relation might associate a person with their corresponding age. Relations can be described in various ways: set builder notation, matrix representation, and graphical representation. Relations are not restricted to being one-to-one, meaning an element from one set can be related to multiple elements from another set, and vice versa. This flexibility allows relations to capture a variety of relationships in mathematics, ranging from simple connections to more complex interdependencies. Relations possess several important properties that help classify and characterize their nature: reflexive, symmetric, transitive, and antisymmetric. Understanding these properties is essential for determining how relations behave in various contexts and for applying them in areas such as database theory, where relational models are crucial. A function is a special type of relation where each element from the first set, called the domain, is associated with exactly one element from the second set, called the codomain. In simpler terms, a function maps each input to a single output. Functions are commonly used to describe processes, transformations, or mappings, such as the conversion of temperatures from Celsius to Fahrenheit. For a relation to be a function, it must satisfy the following conditions. Every element of the domain must be related to exactly one element in the codomain, and no element in the domain can be associated with more than one element in the codomain. For example, consider a function that maps a set of students to their grades. Each student from the domain is assigned a specific grade from the codomain. In this case, the relation is a function because each student has one and only one grade. Functions can be classified in several ways based on their specific characteristics: one-to-one injective function, onto surjective function, and bijective function. Functions can be combined and manipulated in various ways. Some common operations on functions include composition of functions, inverse function, and scalar multiplication. Functions and relations are central to many areas of mathematics and its applications. They are used extensively in computer science, particularly in the design of algorithms and databases. For example, relational databases store data in the form of relations between tables, and functions are used to transform or retrieve information from these tables. In logic, functions and relations help formalize arguments and reasoning processes. For instance, relations can represent logical connections between statements, while functions can model logical transformations or operations. Functions and relations are foundational concepts in mathematics that help structure and model a wide range of phenomena. Relations provide a general framework for associating elements between sets, while functions offer a more structured form of association with specific constraints. Both concepts are indispensable in fields such as computer science, logic, and engineering, where they help solve complex problems and model real-world systems. Understanding their properties, types, and operations allows mathematicians and scientists to build more efficient models, algorithms, and systems.